Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adam Ashraf Saleh and my matrix number is DA220204. And today I would like to do a presentation of the project problem of electric circuit 2. So first thing first, we need to recreate a circuit that were given on the project problem into the multi-sim. So first thing first is we have dual source here and both of them are AC sources. So we need to make sure that this one is AC sources, and then we have a capacitance impedance. Then we put a capacitance here. So for the industrial load, we need to put resistance and the inductance, and for the inductive impedance, we need to put resistors and inductance. So for all the parameters here, since we are from group 3, these are all the parameters that were given to us. Okay, so then what we need to do is we need to find the voltage and the current to make sure that our calculation is correct. So for voltage, we just use a multimeter. And what we need to do is just connect the connection here. So for the capacitance and for the industrial load, we need to connect here. And for the inductive impedance, since the question just asked for the XL, so we just connect the positive probe on the inductors only. So just double click on the multimeter and make sure that the waveform is AC waveform. Here, AC waveform. And just click run. And we can get all the value here, and we can check with our calculation before. So for current, we can also use the multimeter, but we can also use the probe. So just place a current probe here. Here, this one, since the current is the same throughout these two, so we can put it here and here. It doesn't matter, it will give the same result. And lastly, we put the current here. So we just rearrange for a better viewing. Okay, then just click run, and we can get all the value here. And that's all for me, and I will pass to the next presenter. Thank you.
Hi, Assalamualaikum. Good evening. My name is Muhammad Amir Rafiki. Okay, my part for presentation is discussion about calculation, how to find the value in part B. To find the value, we use a multimeter. We use a multimeter and put it in parallel with the component to get the value for capacitor 291.584 volt. For inductor, we get 75.314 volt, and load we get 62.974 volt. And other than that, to find a current value, we use a current clamp to get the current value for capacitor 7.95 ampere. For inductor, we got 1.97 ampere, and for current load, we get 5.99 ampere. Next, from the value that we find the value for V peak using a formula. V peak equal to VRMS divided by set 2 for manual calculation. For simulation, we using oscilloscope waveform, and we can get the value V peak of Xc 147.324 volt with time delay 15.484 millisecond. For XL, we get 106.436 volt with time delay 15 millisecond, and a Z load we get 88.887 volt with time delay 3.125 millisecond. For the I peak, we get the value for I peak Xc 8.522 ampere with time delay 15.484 millisecond. For XL, we get 2.65353 ampere with time delay 15 millisecond, and for Z load we get 6.608 with time delay 6.608 ampere with time delay 3.125 millisecond. For phasor domain value, we use a single AC frequency to find the value for voltage across VT and current across IT. For XC is 291.125 volt with negative 7.793 degree and 6.469 ampere with 82.206 ampere degree. And for the value voltage across VT and current across IT for XL, we get is 74.825 volt with negative 175.709 degree and 1.870 ampere with 98.29 degree. And for the Z load is 62.845 volt with 140.819 degree. And for current across, we get 4.657 ampere with 77.383 degree. For Zmax, we change the value R1 for Thevenin value so that we can find the 65.229 ohms. We also changed the value load from the inductor to capacitor with value 150.29 microfarad to find the value of power max is 287.271 watt with negative 12.531 degree. That's all for me. Thank you.
Hello, my name is Muhammad Arif Hakimi. So I will continue on the presentation for our simulation explanation. So I will explain on the phasor value of current and voltage for the capacitor, inductor, and load. So firstly, we will take a look at our table that we have gained from the simulations. So our table consists of variable, frequency, magnitude, and phase. So the variable is the voltage and current of capacitor, inductor, and loads, and the frequency we use is 50 hertz because it was given in the project that 50 hertz were used, and this is the magnitude for every parameters and the phase. So firstly, we will start with the voltage capacitor. For the voltage capacitor, will get from the simulation is 291.113, and the phase is negative 7.79 volts. But for the simulation, we get 291.04, and the phase we get is 172.22. There are slightly difference between the simulation and the calculations value, but the tolerance is below 5%, so I think it is still acceptable. And for the next, for the VLOAD, we get for the simulation 62.49, and for the phase is 140.82. But for the calculation, we get 62.476, and the phase is 140.82 degree volt. For the VLOAD, we get the same value. There are very small difference. Next is for the V inductor, voltage inductor. This is for the simulation, we get 74.83, and the phase is negative 175.71. But for the calculations, we get 75.2, and the phase is 4.28 volt. They are slightly different, but there are no high difference. So next is for the current for the current for the capacitor is 6.49 6.47, and the phase is 82.2. For the calculation, we get 6.47, and the phase is 82.2. So for the current, we get the same as the simulations. Next is inductor current 1.87, and the phase is 94.3.29. So for the calculation, we get 1.88. For the phase is negative 85.72. They are slightly different, but a small one. And the last one is for the load, we get 4.96, and the phase is 77.38 ohms. And for the calculation, we get 4.95, and the phase is 77.39. So for the load, current load, we get the same as the calculations. So there are just a few that have difference between the value, but the tolerance still below 5%. So that's all from me. Thank you.
Assalamualaikum and good evening. So today, we will discuss about how to find VPEAK with manual calculation and also with a simulation. So, first of all, I will show our circuit. Okay, from the circuit, we find that the value of voltage at capacitor is 229.584 voltage, and voltage at the inductor is 75.314 voltage, and the voltage at a load for R1 and L2 is 62.974 voltage. Okay, from this circuit, we will find the V peak for each component, for capacitor, inductor, and also the load. Okay, for the manual calculation, the formula to find a V peak is voltage VRMS will multiply with square root 2, and we will find the voltage. For XC, impedance of capacitor, we will get 412.311 voltage. For V peak for impedance inductor, we will get 106.510 voltage, and V peak for the load, we will get 89.058 voltage. So this is for manual calculation. Then I will show a simulation on how we get V peak with using a multi-sim software. Okay, so this is our circuit. Okay, so to get a V peak in simulation, we must put in the oscilloscope for each component, for the four component capacitor, inductor, and also the load. So we will setting a clamp to MV per MA, and then for the oscilloscope at a capacitor. Okay, I will show you. First of all, we need to setting channel A, channel B to AC and a single ni. And then the scale for the time 20 millisecond. Okay, so try to run. Okay, to find a V peak. Okay, first choose this and click by max. Then second one by max. So we will get the value for V peak for XC is 412.653 voltage, and the current on the channel B, we will get 9.250 with a time delay 15 millisecond. So the value on a simulation and a manual calculation, we will get same, 412. This is for XC capacitor, impedance capacitor. Okay, next we will go to a second oscilloscope that to find the V peak of inductor. So same thing, we must setting channel A and channel B to AC and a single oscilloscope. Okay, so okay, I will show you first. So for impedance of inductor, we get 106.202 voltage V peak, and 2.827 current on the channel B with 15 millisecond time delay. So we can see the value that we get from a simulation 106.202 is quite similar with our calculation. Okay, for the load oscilloscope, okay, okay. For oscilloscope, for for load, we will get a value 89.740 and current 3.35. So we can see the value for Vpeak on a simulation will be quite similar and on our manual calculation. And for load, the time delay will go on 3.125 millisecond. So that's all from me. Thank you. Okay, okay, sorry for my mistake. Okay, from the oscilloscope for load, we can see the value of Vpeak is 89.740. The value of current is 6.633 and the time delay is 3.125 millisecond. So the value of Vpeak for VLOAD on a simulation and manual calculation will be quite similar. So this is our value for a manual calculation. So that's all from me. Thank you.
Hello, my name is Muhammad Fadil Berosli. Today I will do a simulation for the question 3. Is the question apply the load with Zmax and record the peak magnitude of voltage and current for the Zmax. Calculate the power of Zmax. Okay, first we calculate the power of Zmax first. Here we go to the first we see the calculation. So to find the Pmax, we use the formula VTH power of 2 divided by 8 RTH. First, we find the Zmax. So use this formula, and the value of Zmax is 95.29 minus J21.18. After that, we use the Thevenin method to find the VTH. So the value of VTH is 473.646 with the degree 72.207. After that, we use a Pmax formula, VTH power of 2 divided by 8 RTH equal 473.646 power of 2 divided by 8, 97.62. So the answer is 287.27 watt. For this is the power of Pmax. After that, we go to the circuit to do the simulation. As you can see, we use a capacitor here because at here for the Zmax value we get negative J21.18. So positive J12 plus negative 21.18. The answer we get is negative J9.18. So the answer is in negative. So if negative, we use a capacitor. That's why in the load here we use a capacitor. After that, we click here, single AC output. We pick PR1 plus PC2. Okay, we run. So the answer we get here is 287.27. The answer in simulation and calculation is same. After that, we see the waveform to find the peak of voltage and current. Click here, interactive simulation, and run. Click the oscilloscope. As you can see here, we move here to find the next WiMAX. So we stop first this. So the answer here we get for the peak voltage is 324.74. The current is 3.41 for the peak current. Okay, that's all for me. Thank you.